Good morning, everyone. Holy cow, I was expecting maybe 10. 8:30 last day, everybody's ready to head out. So rewarding you for attending this conference or attending this session. I'm hoping to leave you with something tangible, valuable that you can actually take home and be like, I didn't know that. And I know you're probably thinking, wow, I've seen Zero Trust printed across how many banners of how many vendors. Everybody's talking Zero Trust. It's kind of the free space on your buzzword bingo card. But we're going to talk kind of reality here. My name is Tracy Walker. I've got about 30 plus years in IT, started in operations, software development, and have had a lot of roles. So I've had a lot of experience, especially in high security environments with essentially Zero Trust, but just a lot of security. So we're going to be talking about Zero Trust. We're going to be talking about Kubernetes. I wanted to do the disclaimer. So this presentation is my own. My voice is not warmed up. And I am fighting a little bit of a cold. But so a presentation, this is all my work. My company has not reviewed this. They haven't had any input to this. This is really just me talking about my experience and using a tool to do Zero Trust in Kubernetes. So we're going to cover today what is Zero Trust, some misconceptions about Zero Trust. This is not going to be, the government says Zero Trust is this. No, this is going to be like kind of real world, hands-on experience, misconceptions. We're going to do a real-world example, so I recognize that probably a lot of you do know what Zero Trust is. But for those who don't, we're just going to do some simple examples so that you kind of get a feel for kind of the four things that need to be there for Zero Trust. Zero Trust versus signature matching. So this is kind of the key point to kind of understand the difference when you're talking to vendors or you're looking at software. If Zero Trust is something that you're trying to implement, we'll give you some guides of, well, that is Zero Trust, but this is not. We'll talk a little bit about creating Zero Trust just in Kubernetes without using any tools like native things. And then we will do an example with an open source tool. And that'll be the demo. And that's going to be actually the most significant part of this presentation. So what is Zero Trust? Very quickly. So this is a model. It's not a product. There's no Zero Trust product out there. This is just a model. It's a concept, a framework, if you will. It is basically, it just uses strict access control and identification for not only users, but also devices, network connections. I've been challenged at times that it's all about identity. It's like RBAC. Yes, RBAC is an example of Zero Trust. But it's not necessarily the identity of a user. It is the identity of a device. It's a known identity in a way that you can verify that identity, whether it's a device, a MAC address, whatever the case may be. We can apply this to, as I just said, users, devices, networks, physical locations, or even actions, right? Things that are allowed, we know who performed that action versus things that are not allowed. And these are the four characteristics that I use when I think of Zero Trust. It is first and foremost deny by default. Everything is denied. And then when we allow something in, then we know what it is, who it is, why it is. There is the concept of a perimeter. There is an inside and an outside, right? We have to be able to, security is all about controlling a defined environment. So you have to have a perimeter. There is a method for authenticating who you are or what it is and what it is authorized to do. The network connection it's going to make, the action you're going to perform, the part of the UI you're going to access, those kind of things. And most importantly, continuous monitoring. So it's not just a one stop and go, you got checked and you get to go. No, you're continuously monitoring for any violations of that Zero Trust. So those are the four concepts, right? We can apply these concepts to lots of different things. Misconceptions. So It's not a product or technology, like I said. So anytime you see something talking about zero trust, a lot of times it's RBAC, right? So marketing teams will say, oh, that meets this definition that we learned, and they'll call that zero trust, and on the banner it goes, right? But again, it can be applied to a lot of things, and it's a concept. Zero trust is not all about authentication. Sometimes I've even been told the only thing that's zero trust is RBAC. Obviously, that's not true. All or nothing. So security in depth, layers of security. No layer is perfect. Layers are supposed to work together. So there's also, a thinking that it has to be, that's the only thing you can use. That's not true. Zero trust is expensive. We will falsify that one today because it does not have to be expensive. Eliminates the need for other security? No, obviously. It's a layer. You should have lots of layers, and those layers should be working together to fortify each other. And if one layer, which is not perfect, allows something through or doesn't catch something, then another layer hopefully will. Zero trust only relevant for high security. A lot of times I have heard this, that, well, we don't really have anything that we need that level of security. I define security as anything that allows you to control an environment without impeding the environment. Basically, so if I'm going to implement some security, I don't want it to slow down my software development lifecycle. I don't want it to slow down QA. I want to maintain my velocity of development and deployment, but I don't want to employ so much security that it bogs everything down, right? That's not what we want. So it doesn't necessarily have to be for high security. Again, these can be just layers of security that support what you're trying to secure. So an example of real world, if you're flying through Denver tomorrow, that's DIA. So real world example of zero trust is TSA checkpoints, right? There is an enforced perimeter. You can even see the perimeter right there where the x-ray machines, once you enter that perimeter, you're in a sanitized environment. That perimeter, which includes all of the the terminals where you get on planes, that's a secure environment. And that's the perimeter of that environment to get into it. After you land and you go to pick up your luggage, you always hit this point where they say, if you go past this, you cannot go back. Even if it's 5 feet, you go greet somebody, oh my gosh, I forgot my phone. You cannot get back in. You could have met somebody outside that perimeter, they could have handed you something, and then you try to get back in. Nope, you're not allowed back in. So there is an enforceable perimeter here. It is deny by default, deny all by default. So all of those people on the outside of that at this point are not allowed in. How are they allowed in? Well, and what are we securing here? So users and weapons, so users, or the people, essentially are not allowed until they authenticate themselves and are authorized to get through that perimeter. Weapons are not allowed through that perimeter, right? Weapons can include jars of peanut butter, right? Or jars of honey, right? So there's a list of things that you're not allowed to bring in, and they will check you for that, as you know. So you have to be authorized, which means basically you have a ticket to get on a plane, or you're a service worker, you're a pilot, you're somebody who works within that perimeter. You have to be authenticated, you have to show them your ID, who you are, and that has to be matched with your ticket. And then you will be checked, and everyone is checked. It doesn't matter if you fly every day, if you're a pilot, you're a service worker, everybody has to go through those x-rays, right? Because this is a sanitized environment. It's deny all by default, right? Nothing is allowed in unless you follow all of those rules. And then, of course, if you have something, they'll take it away from you. They might let you in without that, but that's how that zero trust works. Continuous enforcement. So if you want to test this, open a door to the jetway or try to get onto the tarmac or something like that. You will discover continuous enforcement. They will know that you went through that door, the alarms will go off, somebody will come and escort you to another room where they'll have a conversation. This is not the only thing that gets checked, right? There's also the concept of a no-fly list. Now, a no-fly list is not zero trust. A no-fly list is basically threat detection, threat matching, right? Why is a no-fly list not part of Zero Trust? Because if you get authenticated, you have a ticket, you showed them your ID, you've been x-rayed, but there's one more check. Is your name on this list? Oh, Tracy, you're not allowed to fly today because you got a speeding ticket somewhere or whatever the case may be, right? So that is not deny all by default. That is deny these things on this list, right? So that is another layer of security, right? That layer of security is not part of the Zero Trust, right? Because that is not deny all. So we deny everybody, and if they pass those criteria, they're authenticated and they're authorized. But the no-fly list, that's another layer of security so that even if you had a ticket and you got the ID and you're thinking you're going to get through, if you match that list, you will be denied. But that list is not deny all by default. It's allowing everyone, but denying these people on this list. Does that make sense? And by the way, if you have questions or I don't agree with that, feel free to raise your hand. You can step up to the mic and we can talk about it because we're all here to learn. All right, so some examples, Zero Trust versus signature matching. So first, most popular thing, CVEs. Scanning for vulnerabilities, scanning for exploits. That is threat and signature matching. We're looking for something that matches a particular version of a file or something like that we know has an exploit, and that's how we flag that, right? DLP, data loss protection, that's usually scanning network traffic to identify patterns like credit card numbers or something that's PII. Network attack detection, that's very much like that no-fly list. If we detect a type of attack, we want to block that attack, right? Do we have a complete list of every known attack? No, we do not. There are things called 0 days. A 0-day attack is an attack that hasn't been defined yet. Once it's defined, it is no longer a 0-day. It's a CVE that has been published. It has a name, log4j, whatever the case may be. And so it's still just a list. It's not deny all by default. It's deny those network attacks. WAF rules that check things, looking for different types of attacks in network traffic. And admission control rules like allowing images to come into a Kubernetes environment. That too is more of a list of checks that we're just going to verify. Zero trust controls could be network policies, so essentially deny all by default, and here are some allowed network connections. Container processes could be, because we know what processes can run on containers. And so if we could have an allow list of those processes that are allowed, and anything else that's not allowed, we can enforce and continually monitor for. That could be Zero Trust. And we'll look, and the example and the demo we'll do today, we'll show examples of network policies and container processes that will do that. Registry orders, so I've seen admission control rules that say, I only want to allow images in my Kubernetes cluster that came from X registry. And if it comes from any other registry, I don't want to allow them. That's Zero Trust. My perimeter is my cluster. I'm denying all images by default, but I will allow these images that come from this location, and assuming that means they're authorized and authenticated to be downloaded into my cluster. And of course, RBAC that's in Kubernetes. So kind of on that vein, what we're just kind of talking about, what would Zero Trust look like in Kubernetes if we were just kind of doing it from what's available there. So we know we can, these are the things we want to control, right? So we would like to control what images run in an environment. We want to know that. We want to know which users are in there. It would be really nice, and there's a lot of tools that use like extended Berkeley packet filtering, eBPF, very popular technology, love it, that allows you to see container processes that are running inside an environment. As well as the network connections inside the cluster. So this is where it gets into a little bit of a gray area. A lot of products will talk about that they can see network traffic, but the source of truth of where they're getting that information of where that traffic has come from, that's kind of a key security concept, right? What is my source of truth? Where am I getting that information from? Do I have other sources of truth that are independent of that validate that? Or is this the only place I'm getting it and it relies on this thing over here that Well, if that was compromised, then maybe I'm getting the wrong information, right? SolarWinds is the best example of when your source of truth is compromised, you don't know what's going on, right? If it's being obfuscated from that source of truth, from your security tool, that makes things a little bit difficult because you tend to trust your security tool. So, what is built into Kubernetes for Zero Trust? Not a whole lot. There is RBAC. There is Pod Security Admission, which is the new version of Pod Security rules. Might give you some abilities to do some of that, like a registry lockdown. Network security policies, the way that they work kind of natively in Kubernetes. I don't have enough experience knowing if I'm only using Kubernetes policies, network security policies, those tend to be like layer 3, layer 4, maybe not layer 7, and so I may not have a way to necessarily validate what's in that traffic. So it may give me, this is the route we want this particular service to use, but am I denying anything else from happening? Am I continuously monitoring? That's where it comes a little bit questionable. And of course, container processes is something probably we can't do just natively in Kubernetes. So if you're wondering, well, wait, I thought this was supposed to be zero effort, zero trust for blocking 0 days, right? That's kind of the magical thing. Many of you may have decided to attend this thinking, this is complete bunk. There's no way you can do zero effort, et cetera, et cetera. So what are we really talking about here? Well, what's the actual effort? So assuming that if you're attending this session that you have some familiarity with Kubernetes and container environments, the actual effort is being able to deploy an open source tool in your Kubernetes cluster. If you're using Helm, you're using kubectl, 5 minutes to deploy this open source tool. Will it really implement zero trust? Yes, we'll show you that. How would it detect 0 days in a Kubernetes environment? Well, we will show you that because when we're doing zero trust and we're saying, well, this is allowed, this is authorized and allowed, that's in a sense kind of giving us a signature, if you will, for what's allowed. Anything that is not allowed becomes outside of that, it becomes suspect, right? So if we know what is supposed to be the behavior, anything that is not that behavior becomes an alert for we don't trust that, right? We only trust these things. Okay, zero cost, there's no way this is zero cost. Other than running the infrastructure that you may be paying for, the open source tool we're about to talk about is completely free, 100% free. We will talk a little bit more about that. What about the risk? So this has got to be complex, it's going to bog us down, et cetera. No, actually you can do this in a way that alerts you to things without necessarily blocking things. So the open source tool we're going to talk about has the capability of actually blocking and preventing anything outside your zero trust perimeter, right? It's continuously monitoring everything that's happening. So then it's the performance, that's the gotcha. Actually, no. The way that this tool works is unlike any other tool. And it does this differently and it doesn't use eBPF. It's air gap capable, things like that. So it really just runs inside the cluster. You deploy it in the cluster. You set up a couple of configurations that literally take 120 seconds, 2 minutes, 5 minutes, and you're already set up to go. Okay, so a little bit of disclosure here. So when I submitted this talk, and to give you a little bit of background, the talk was supposed to be on a tool that has been submitted to the CNCF called Open Zero Trust. Open Zero Trust is basically the donation of the source code and tools for a commercial product that has been offered at enterprise for about the last 7 years called NeuVector. NeuVector was a company that was acquired by SUSE. If you've heard of SUSE, kind of famous for open source Linux. They acquired Rancher 3 years ago, and then about 1.5 years ago, they acquired NeuVector. And what they did is they took that enterprise licensed software and they made it available to everyone as an open source project, which is a little different. Usually open source projects have communities and kind of start with grassroots efforts and those kind of things. But when you take a product that traditionally you've had licenses for how many nodes you're going to run it on, all that kind of stuff, and you make it free for everyone to use, there's no community there, right? It's kind of like, sure, it's free, really? Couldn't have done much if it's free, right? Not in this case. The thinking behind the reason why this was made open source was everybody should be able to use it for security. Yes, SUSE will sell you support if you need support, but there are no limitations. You don't even have to sign up for anything. You can rebuild the images, the build tools, the documentation, the images if you're using those, and all the source code is completely open source and available for the public, and those are where you can get that information there. Any questions about that? So the reason why this is going to show NeuVector and not Open Zero Trust is because the first submission did not pass. That took place between the time I submitted the talk and today. It is going to be resubmitted. Again, the project name will be Open Zero Trust, and that will become the upstream project that then will flow down and NeuVector will continue to be built on. Okay, so we're going to go through a little demo, and in that demo you're going to see some screens that look like this. And so I want to highlight a couple of things that you're going to see before we actually get into that demo, because then we're going to be off the PowerPoint, right? I know what you're thinking, thank goodness. The policies that you look there, the first thing you'll notice is see how the action says allow? So at the bottom of this list, or these are a list of all the network rules, and at the bottom of this list there is a deny all. Deny all by default, right? So like firewalls, I remember back in the early 90s when they used to send us firewall hardware, and they would always have the default ports open for all the popular things. I know you're thinking, early 90s? Yeah. Like FTP was open and HTTP was open. And you would receive these security devices with some kind of default configurations because in the early days, it was all about just making sure everything worked, right? But then as security concerns began to rise, then they started shipping all of the firewalls with deny all, like everything was shut off, and then you had to intentionally open all the ports, which is essentially what we kind of do today. That was the change. That was essentially establishing a little bit of a zero trust. Deny all by default. You'll probably have an Excel spreadsheet with all the ports that you're going to open and who authorized that port and when things change. So that's not fast, right? Again, this is supposed to be zero effort. Container processes. So here's a list of container processes, and see that it's got allow rules. So oftentimes I'll see someone say, well, I want to deny this connection, or I want to deny this process. You don't have to build deny rules in Zero Trust because Zero Trust is really using allow rules. It's deny all by default, allow these things. If I was denying these things by default, that's not deny all. So that becomes that threat list, that kind of matching that we do there. So here's how we're going to do this demo. So I'll show you this open source tool. And this tool uses some discovery mode, which actually learns the behavior of an application. So it's going to identify the network packets. It's going to identify all the processes that are running on all the containers. And it's going to automatically build that list of all the things that it has seen, right? And then we have a monitor mode, which basically turns off the learning. So once it creates this list, and you may want to verify that list, but once it turns off that list, it won't make any more rules. So anything that happens after that, it will alert you to, and so alert only. So this is why it's zero risk, because if you're in the monitor mode, it is not going to block anything. As a matter of fact, the way the tool actually works is it taps the traffic off of the VNIC of each individual worker node. So if you have a 10-node cluster, you're going to have 10 containers running on each node that's tapping the traffic off of the virtual network interface. So it's not using Kubernetes. It's not using IP tables. It's an independent source of truth where it's getting the information for network connections. There is a protect mode, and that protect mode will block any process or network connection. This demo will not include that because that's not zero risk, right? We want to validate our rules, make sure that what we're going to allow is everything we want to allow. We haven't missed anything. We don't want to accidentally block something. So that's kind of the advanced topic for there. Oh, excuse me, sorry. All right, so finally, to the demo. So what you're going to see me do, we're going to look at some security policies. I'm going to delete those. We're going to start fresh. You're going to see new security policies being created. I'm even going to create some by shelling into this container, right? So it's a single container. This is kind of a conceptual thing. I'm going to move that container to a Discover mode. We'll learn the rules. We'll add some to it. And then I'm going to move it to the Protect blocking mode because I want you to see what happens with the Zero Trust. Then we're actually going to do an attack. So I'm going to launch an attack against this website. You will see that we can detect the attack. That will do threat detection, so it will block the attack based on the attack. Again, that would not be Zero Trust, but that will help us understand when I move to the monitor mode where we don't block anything, you will see the entire kill chain of that attack. You'll see, well, half of the commands. Unfortunately, I don't have control of the firewalls on this wireless network, so I can't actually have an active listener receiving the reverse shell and launching a reverse shell. They won't let me open the ports necessary to do that. But you'll still see what I'm talking about. Okay, let's get to that live demo. All right, this is NeuVector, and down here under the groups, and this is, let's make this a little smaller so we can see what's going on here. So I have a bunch of containers running in this environment. And in this environment, this container right here is running this website right here, right? So this is just a really easy example of how to do this. And you can notice down here, so I'll scroll up, that we have some process rules. So this is running a Java application on Tomcat Apache. POS is a Kubernetes process. It's always checking things there. So it's learn those behaviors. If I were to look at some other containers, you can see there's other process that have been learned, like a Redis server. It's using find and pause, right? So these processes, let's delete these. All right, no process. And notice it's in the monitor mode. Even though I have deleted the processes, all that means is now those processes will show up on the alerts, like what's Java doing? I don't trust that. Network rules. So we've got some HTTP rules, SSL traffic. So these are all managed under the network rules. Again, as I said at the very bottom, there is a deny all right there. So let's delete these 3 rules. So there won't be any rules to worry about at the moment. All right, starting fresh. There are no network rules, as you can see. There are no process rules. So now we're going to move to our Discover mode. We're going to learn the behavior of this application. So how do I get this free to use open source tool to do this? Let's just exercise the application. I'm going to refresh this. I'm going to create an order for it. So let's create an order. We'll hit submit there. I've generated some HTTP traffic within that cluster. If I come back to NeuVector, let's refresh those process rules. That's what we just saw, right? We saw Java, we saw POS, there they are. Network rules, we're seeing HTTP traffic. Takes a few seconds to generate the extra rules, but it's coming. Let's make this just a little bit more interesting. So I'm going to shell into this container. Nope, not with that one, sorry. I grabbed the wrong line. That's the attack. Let's not do the attack first. Let's do that one. Awesome. Who am I? I'm root. In security, that would be your worst nightmare, that someone has privileges like root inside your cluster. That's not good, because I could do all these things. Let's do a DU there. How about a wget to Amazon.com? Doing that to create some extra network traffic, like a ping or something like that. What does NuVector have to say about this? Because I thought we were we're in the discover mode. Well, there you see the wget, there's the ls, see the du. That who am I, that's part of BusyBox. So this tool is seeing every process real time that this is happening, right? Network rules, yeah, there's DNS. I hit www.amazon.com, right? So we're seeing that as a layer 7 protocol, and we are making a rule for it. All right, well, like I said, we're gonna switch the mode now to protect. And again, this is the riskier mode. This isn't going to be the mode I recommend in a moment, but I want to show you how this works. And before we continue, we know that the bash and the who am I and the commands that you just saw me running are not part of my normal application behavior. That's what Tracy was doing in this shell, right? So let's remove those. All right, we're back down to the Java and pause. For speed, we won't do the network rules. Let's go back to our open session, right? I just removed those rules. And if this is zero trust, it won't allow me to do these things. I am root, not permitted. ls, not permitted. du, not permitted. How about remove, what is it? Recursive force star dot star. Not permitted as root. So this is able to stop an attack as it's happening while I'm in an active session in that container. That's zero trust. We don't trust those commands. We're not allowing those commands. If I were to exit this container, is bash part of those rules? No. I can't get back into the container. I've lost my session. It won't stop an active session, but it'll prevent any subsequent sessions. And it'll prevent you from doing anything that once you're in that session. Okay, let's now do the attack. Let me get the command again. All right, so this is going to use, this is a fairly old remote code execution. Basically what this is using is Netcat for a vulnerability in Apache. This is years ago, so I think everybody's got this patched. This container is not patched. And if you're thinking about this, zero trust can protect me against unpatched CVEs. Because what's the difference between an unpatched CVE and a 0-day? Nothing. I mean, it's activities, it's processes, network connections that you don't trust, right? So I'm gonna hit this with this attack. It's using Netcat to basically create this reverse shell. Because I can't open the 1337 port and have a listener working, it's not gonna make the actual connection, but you will see what it's trying to do. So let's run that command. Uh-oh. What is happening here? We tested this. It is. The demo gods are unhappy. Let's double check the struts attack. That all looks right. And I'm pretty sure, oh, that's why. There's no address for that. So let's fix that. Thank goodness I could figure that out. That's the problem right there. Apologies for that. So we're going to use this IP address right there. That looks right. Excellent. That's what we were looking for. Nothing's happening. Well, something is happening. If I go down here to my security notifications, security events, there's the bash. Let's hit a refresh here. Well, you see there's a bash deny right there. I want to double check one more time. That's the right spot. and I'm not seeing, but it is blocking it, so that's why I'm kind of confused here. Yeah, it is still getting blocked. It might be getting blocked for another reason. I could show you down here that we may, well, there you go. There's what I tested 9 hours ago. This Apache Struts remote code execution. So when we see the threat, we can block it based on the threat, right? That's not zero trust. That's using threat detection. We don't ever have a complete list of every possible threat that can be happening here. And it does grab an automatic packet capture that shows what is being run there, so we can detect the threat. There you can see the netcat right there at the bottom with that IP address. So, yeah, but it is, I do feel that it's working because my attack is not actually getting through. So I'm gonna hit refresh one more time there. Well, let's do this. I'm gonna go to my policy groups. We'll see if I'm actually hitting the right place, because as part of what we're gonna do here, we're gonna move it to monitor mode, and we're not going to block this attack. Let's try it again. It did time out, so the behavior is consistent, but it's still getting blocked. I'm so confused as to why that's not working there. 37. I am positive I'm hitting the right place. I am so sorry that this is, I don't appear to be actually doing. Yeah, I'm still not seeing it. Let's do one quick check. And apologies for watching somebody troubleshoot, because this is not how we want to see this. Yes? It's 34, 35? So that's the 34. This is the website I'm trying to attack. And I think doesn't that look right? And I have an order 3 there, 3470, 8080, super app orders. Super app orders. If I hit 3, let's do this whole thing right here. IP based. Oh my gosh, sorry. There we go. There we go, let's try that. The other IP is supposed to be my IP address here, but that is, it shouldn't even actually matter unless it is something. It still acts like it is hitting a different website. It is getting blocked, so I'm. Yeah, the new vector is this one. Is not the 3470, 186, 245. Let me try one more thing. Firewall might be blocking something. So let's refresh this page, make sure we still got an active connection. Excellent. 2 minutes of Q&A. Well, let's try it one more time. Because we're on the time. So there's the timeout. Look. Well, looky there. It was the network. So really quickly. Here you see, a few seconds ago, Apache Struts remote code execution, right? Also notice the netcat. There's the shell. So like I said, I can't get the reverse shell to come all the way back, so it won't make that connection. But if you ignore this, see that netcat and that shell, and any other network connection being made gets alerted to, right? That's the zero trust. So how can you do this with zero effort? Well, what did we learn today? So super easy to deploy NeuVector into an environment. It may take you 5 minutes. Use Helm, just use all the default values. Not suggesting that you integrate it with all your tools and your SIEM and all that kind of thing. Just deploy it, and you'll immediately, so when it deploys, it's immediately in the Discover mode. The other way to automate this is when you move it to that Discover mode. If you go here to the settings, configuration, and you go to this service group automation, you can automatically move from the Discover to monitor mode, and you can do that within an hour up to 30 days. So you can just let it run into Discover mode for as long as you want, and then it'll automatically move everything to monitor mode. As I mentioned, don't move to the protect mode because that would start blocking things and you want to do some advanced stuff with that. So if you just select that box right there after you install it, that's it. You're done. So yeah, it'll learn all the policies. It's going to learn all the policies for both your network and your processes. It'll be able to report on network attacks if you happen to have any. I've experienced situations where we deployed it and immediately discovered there was like a SQL injection attack being automated against the cluster. It does scanning for vulnerabilities and security misconfigurations, but literally within minutes, you should be able to secure any workload. You can deploy this strategically. You can deploy it into a cluster, turn on that Discover monitor mode, and then have that real zero trust that is fully automated and based on your application's normal behavior. So step by step, deploy it. Step 2, do that service mode automation. And that's it. Go have a cup of coffee. Then you would log into the UI, or you can look at the logs and you can see any security events or violations of that zero trust. Any questions? Thank you so much for sitting through my troubleshooting. That was fun. Yeah, that was fun, wasn't it? Is everybody sweating as much as I am? Any questions or thoughts? Yes.
I have a question.
Yes.
First of all, thank you for the great session. I have 2 questions. One question is that does this tool support, like for example, the Azure Kubernetes or?
This tool will run anywhere you're running Kubernetes. If you're running Kubernetes on GKE, Azure, in the cloud, on-prem. I've seen this running on workloads that are running on airplanes in flight, running Kubernetes clusters. So there's no SaaS components. There's no license. You download it, you install it, it's 100% free. There's no limitations. You can use it everywhere. So any cloud environment, anywhere you're running Kubernetes, OpenShift, Tanzu, anything that's based on Kubernetes, it generally works exactly the same way.
Great, thank you. Second question is, can the events be integrated with SIEM?
Yes, so the tool is actually built to be integrated with the SIEM, or there are other integrations. So like Splunk, Datadog, things like that. It exports all the logs via syslog. So anything that can accept syslog logs, it will report on. It does have an admission controller, so there's a validating admission controller to report on that. Any of the runtime or network violations. It also does file access violations. So this is kind of the tip of the iceberg of what the tool can do. But as I said, it's free to use. It's open source. Anybody can use it. You do not have to contact SUSE or for anything. You don't even have to give an email address. It's kind of built to run everywhere as easily as possible.
Great, thank you.
My pleasure. Any other questions before we end? Thank you again.